All right, so this is Archimedes' principle, and the basics of Archimedes' principle is written here, but we can say it in words. It's the buoyant force is equal to the weight of a displaced fluid. So anytime anything is submerged, that's what the buoyant force, you can calculate it as. Now the weight of the displaced fluid is the volume of the fluid times the density of the fluid times g, the acceleration of gravity, 9.81 meters per second squared. So our basic design is we're going to make a couple measurements. One is we're going to measure the weight of an object. We have a few different types of metals to choose from. And we will next measure the weight of the object when it's submerged. So we wouldn't call that the weight anymore, we would call it F2. Now that's just the difference of the weight as opposed to the buoyant force. So we know that the measurement of force while it's submerged will be less than the weight of the object because the buoyant force is acting upwards. And our goal is to measure the density of the metal. That's what we call rho metal. Don't confuse that with the fluid. That's going to be for water. So we have rho, Greek letter rho, the density of the metal. That's what this represents. And we can calculate that based on our previous measurements as just discussed. So let's take a look at our experiment.